Welcome to this lesson on strings. As you'll learn, C programs make extensive use of character strings. We've used strings when we printed out "Hello World" and other messages to the screen display. In this lesson, you'll learn how to create your own character strings. You'll learn that C stores a character string in consecutive memory locations, and that we place a special character, the null character, or ASCII 0, at the end of the string to mark the last character. So let's go ahead and get started. And so as we said, C stores character strings in memory in consecutive memory locations, and then we place the null character at the end of the string so we know where's the last character in the string. And so when we have the program right here that prints "Hello World," we pass the character string to the printf function. Behind the scenes, the C compiler actually passes the starting address of the string to printf. It then looks at the character at that memory location and says, is it null? If it's not, it prints it. And then it goes to the next character. Is it null? If it's not, it prints it. And it repeats this process until it finds that null character, and that's how it knows where the string ends. To create our own character strings, we create an array of characters. In this case, we're creating an array named string that's capable of holding 64 characters. We then initialize that string to the string "Hello World." And so the first 11 or so characters of the string will be the words "Hello World," and the 12th position will be the null character that marks the end of the string. To print our string, we can just pass the name of the string to printf. It in turn will go through each character in the string, checking to see if it's null, and if not, displaying it. When we create a character string, we don't have to specify the size of the array. As you can see here, we just specify string with the brackets to indicate that it's an array, and we initialize it to the string "Hello World." Behind the scenes, the C compiler will allocate enough memory to hold "Hello, World" plus the null character. To use that string, we just pass it by name to the printf function. It will look at each one of the characters in the string, displaying them until it encounters the null. We can also declare string variables by using a pointer to a character. In this case, we're creating a pointer to a type char that is named string. We initialize that string to "Hello World." Behind the scenes, again, the C compiler will allocate enough memory to hold our string plus null, and so we can display our string just by passing its name to the printf function. Printf will receive our pointer, which points to the first character in the string, and we'll look at those memory locations until it finds null. A common operation your C programs will perform is to loop through the characters that make up a string. In this case, we're creating a string array capable of storing 64 characters. We're initializing it to "Hello World" plus the null character, and so much of the array is unused. We then use a for loop to loop through, looking at each one of the characters in the array until we encounter the null character. So we're going to look at the first character. If it's not null, we're going to print it. We'll then increment our index and look at the second character. If it's not null, we'll print it. And we'll repeat this process until we encounter the null character, and our loop will end. So this program performs identical processing as the previous one. It's going to loop through the characters of the string array. What's different about this program is the condition that it's testing for. In the previous program, we explicitly tested, is string sub I not equal to null? Well, the ASCII character is ASCII 0, and you've learned that C treats 0 as false. And so in this case, our loop says, keep looping until string sub 0 is false, or 0, or the ASCII null character. You'll see this shorthand notation a lot as you look at C programs. So it's important that you understand that in C, a character variable is different than a string variable. In this case, our program is defining a character called A, or named letter, and assigning it the value A, and creating a string named string and assigning it the character string in double quotes. The double quoted string has the letter A plus null. The character variable only has space to store one character, and so it only stores the letter A. So that's the difference between a character variable and a character string variable. And we can confirm this by using C's size of operator. We'll pass both the character variable and the character string to the array. The character variable should take a byte of storage, whereas the character string should have 2 bytes, one for the letter A and one for null. When we run this program, we see the following output. And sure enough, our character requires 1 byte and our character string required 2. When we declare a character string array, you've learned that if we don't specify the size of the array, C will allocate enough storage to hold the letters we specify plus the null character. So in this case, we have a first named string. It doesn't specify the size of the array. So instead, C will allocate behind the scenes memory to hold the letters KRIS plus null. So essentially 5 bytes. We then specify the size of our character array for the last name variable. And so when we do this, one of the things that you need to keep in the back of your mind is something called a buffer overflow. And so what happens is a buffer overflow occurs when we access memory that's outside of the target variable. So in the second program, we have our first name variable, which has 5 bytes, and we have our last name variable, which has 64 bytes. But our program tries to assign to first name sub 5 the value B. Well, first name sub 5 is a buffer overflow. The first name variable is only first name 0 through first name 4. And so when we run this program, we see that although we're trying to manipulate the first name variable, we overrode its buffer and actually impacted the last name variable, changing the J to a B. So when buffer overflow errors occur, sometimes it can be minor like this. This is something we just have to debug and say what went wrong. But in other times, we can overwrite key parts of memory and cause our program to crash. And we'll see some examples of that later. Over the course of time, the C standard library has deprecated, meaning stopped supporting some of the older functions that could lead to a buffer overflow error. One of those functions was gets, but you'll see gets used in a lot of older C programs. And so what happens is, in this case, the program's going to prompt the user to enter a string. It's then going to read the string that they enter using the gets function, which is built into the C programming language. Gets reads the keyboard and gets the characters that the user types. In this case, it's going to assign them to the buffer string. You can see that our string variable has space for 64 characters. If the user were to type more than 64 characters, we'd have a buffer overflow. And so as such, gets is a somewhat dangerous function. And because of that, the C compilers have deprecated it. If we try to run this program, the compiler will give us an error that says the use of gets is dangerous and should not be used. And so again, this is only a compiler warning. And we've talked about the fact that when you see compiler warnings, you should correct your program until you eliminate them. And we'll look at other buffer flow opportunities. But if you see a message that says a function's been deprecated, that means the compiler no longer supports it, and your program should not use it. When we work with strings, there may be time where we need to embed a single quote or a double quote. So in the first case, we want to say, that's incredible. But that single quote by itself will confuse the C compiler. So we have to put the slash in front of it, making it an escape sequence. Likewise, the double quote typically marks the end of a string. But in our case, we want to be able to have a quote within our string. And so we can use the slash double quote as an escape sequence that just says, don't treat this as the end of the string, but rather treat this as a character in the string. And so if we print this output or run this program, we can see our single quotes and double quotes made it into the output. I'd take time to experiment with this program and may delete those leading slashes and see the syntax errors that develop. As we work with strings, it's often important to know how many characters are in a string. Now we know that the C compiler places the null character at the end of strings, and when we do string manipulation, we have to place the null character after the last character of a string to mark its end. In this case, we're declaring a string variable called string and assigning it the double quoted string hello world. We then have a variable called length, and we're going to use that variable within a for loop to say, look at the first item, length is equal to 0, and as long as the character that's being referenced by string sub length is not null, increment length. And so that's all we're doing in our loop. We have a null statement, or just a semicolon. So we're just looping through the characters of the array, counting them. And when the loop ends, the program uses printf to display the number of characters. So when we run this program, it tells us the string hello world has 13 characters. The second program does the same thing, but it simplifies our condition and doesn't explicitly test if string sub length is not equal to null. It just says keep looping until we encounter the string or the null character within string sub length. And so when we run this shorthand notation, we again get the string hello world has 13 characters. Because your programs will need to know the length of the string, the number of characters that the string contains on a regular basis, the C standard library provides a built-in function called strlen for string length. This program uses it. The strlen function is defined in the header file string.h. And so our program declares a string variable, initializes it to hello world, and then displays the number of characters that our string contains. When we run this program, we'll see the following output. In a similar way, an operation that your programs will often perform is to copy the contents of one string to another. To help us do so, the C standard library provides a string copy function. And the format of the function is copy the old string to the new string. And so in this case, we have a string variable that we've initialized to hello world. We then have a new string, character string array, that doesn't have a value. We're going to copy the value of string into new string and display their contents. When we run this program, we'll see the following output. The old string contains hello world and the new string contains hello world. And again, you need to be careful when you use string copy. Make sure that your new receiving buffer is large enough. In this case, we both had character strings that were capable of storing 64 characters, and so it's a pretty safe operation. But you need to be aware of buffer overflow errors. So this program uses the string copy function that we just discussed. But in this case, we don't have a buffer that's large enough to hold one of the strings, and we're going to get a buffer overflow error. So let's take a look at where our processing is happening. The first, we declare our string array, named third string, and we initialize it to Chris Jameson. Then we create a new character string. It has space for 5 characters. And then we create a third string that has a message hello world in it. We copy our string to new string. Now the string that we copied, it says hello world. And so when we display that, it should be correct. The problem is that we had 12 or 13 characters in hello world that we copied to a character string array that's capable of holding 5 characters. That means something's going to get overwritten by our buffer. So let's take a look at the output. It says old string is hello world, new string is hello world, but the third string, which should have been hello world, is just comma world. It's been partially overwritten. And so as you're using routines like string copy, you need to be aware that buffer overflows can occur, and you need to try to take steps to prevent them. Make sure you allocate enough space for the number of characters you're working with, and periodically test that you've not overwritten the buffer. Just as there's times when we want to copy one string's contents to another, there may also be times where we want to append one string's contents to another. And so here we'll show how you do it manually. First we start out, we've got our string that says hello, we've got a second string that says world, and we want to append that second string to the first. So what we do is have a loop to find the last character of the first string. So you can see we have a for loop, for equals I, as long as string sub I is not null. Just keep looping. And when we finally find null, we can then append the second string. And so the way we do that is to start at the first character of the second string and assign it to, in this case, string sub I. And so look at what our test is. It's testing an assignment. And we talked about the fact that C compiler supports this. In this case, our loop is going to continue as long as the value that we assign to string sub I is not null. And so within our increment portion of the loop, we use the comma operator to increment the index of the first string that we're appending to and the second string that we're appending from. And so we're going to just keep assigning characters from the second string to the end of the first string until we assign the null character. And so when we run this program, sure enough, we see hello world. And you can see in this case, we didn't have a space in either one of the strings, so we get hello world bunched together. And so it just appended right at the end of the first string the contents of the second string. Again, when you perform string append operations, you need to have buffer overflow errors in the back of your mind. Because appending one string's contents to another is a common operation, the C standard library provides the strcat for string concatenate function that you can use to append one string to another. In this first program, we've got a string that says hello and a string that says world, and we use this strcat function to append the contents of the second string to the first string. When we run this program, we see our hello world concatenation just like we previously saw. The second program makes up for the fact that we didn't have the comma and space in it. And so the first thing it does is it concatenates the string with a comma and a space to the end of the first string. Then it appends the second string to it. And so when we compile and run this program, we see our hello comma world, which is what we typically see throughout this course. When you append the contents of one string to another, there may be times when you don't want to append the entire string, but only a specific number of characters within the second string. To help you do that, the C standard library provides the strncat. The N stands for the number of characters you want to concatenate or append to the end of the string. In this case, we have the strings hello. The second string has the content world peace. When we do our concatenation, we only want to grab the first 5 characters of that second string. So when we run this program, you can see we see hello world, and it's ignored the characters, the space, and peace. That's because when we called strncat, we specified only copy the first 5 characters. So take time to experiment with this program and change that 5 to a 6 or a 7 or 8 and see the processing result you get. And so you've seen how to use the strcopy function that's built into the C standard library to copy the contents of one string to another. In addition, the library provides the strxfrm function, which allows you to copy a specified number of characters from a second string to a new string. So you're going to overwrite the first string's contents with the number of characters you specified from the second string. And so in this case, we have our strings. One has hello, one has world peace. And we're saying copy the first 5 characters, which should be the word world, from the second string and assign it to the first string. When we run this program, we see that sure enough, those 5 characters have been copied. Another common operation your programs will perform is to test, are 2 strings the same? Do they have the same characters? And so are they equal? And so what we can do is loop through both of the character strings. Compare the first character in one string to the first character in the second string. Are they the same? If they are, keep looping. And so we do this as long as they're equal and one of the strings has not yet reached the null character. And so if they're not equal, the they're going to fall through the loop and the loop will stop. But if they are equal, or at least up to the first 10 characters are the same, if one of them has 15 characters, but the first 10 characters of both strings were the same, we're going to loop and loop and loop, but ultimately we're going to find one of the strings is null. And so we need to test for a couple things. One, we test for, are both the strings null? And if they've both been equal to this point, then they're the same strings. Otherwise, we say, is one of the string, are the characters the same, but one of the strings is shorter? And so we have to check for that. And so there's a lot going on in this program. When we run it, it will tell us that hello world and hello world are the same. But you can see that the third string differs by the fact that it has an exclamation mark. So it's different. And so we had the first two for loops looked at the first two strings, and then the second for loop looked at the second and third string. And so the first two strings were equal, and the program detected that. But the second string was slightly longer, and so they weren't equal. And so because determining whether or not two strings are equal is such a common event, the standard C library provides the strcomp for string compare function to determine if two strings are equal. And it will return the value 0 if the strings are equal, or it will return -1 if the first string is less than the second string, or 1 if the first string is greater than the second string. So let's take a look at our previous example. We've got our three strings, and the first two have hello world, and the third one has that exclamation mark at the end. So it's not the same. But let's take a look at the values that strcomp returns. So in the first case, it says hello world and hello world are the same. They're equal to 0. In the second case, however, the second string is going to be larger, and so strcomp is going to return the value 1, which causes our if condition to fail. And so you just learned that using the strcomp command, you can compare two strings to determine if they're equal, if one is less than the other, or one's greater than the other. In addition to strcomp, the C standard library provides the strncomp function that compares the first n characters of two strings. So in this case, we have three strings. Two of them have the contents hello world. The third one has hello mundo, where mundo is Spanish for world. And so our program takes a look at the first two strings, but only the first 5 characters of those strings, and says whether or not they're the same. And then it compares the second and third strings, but only the first 5 characters of those strings to see if they're the same. And so let's run this output. And so it tells us that hello world and hello world, the first 5 characters are the same, and hello world and hello mundo, the first 5 characters are the same. So depending on what the content says of the strings you're trying to compare, you may want to use the strncomp function to limit the number of characters that are compared. When we compare strings, there's times where we want to consider upper and lowercase characters the same. Assume, for example, that your program stored a user's email address. Later you ask them to log in by using the email address. They might type part of the email address in uppercase, part of the address in lowercase, and so you want to be able to just match it to the email address so you can ignore the case when you compare the two strings. And so the code here allows us to do just that. We've got our three strings, hello world, and then hello world with an exclamation mark. You can see that the second string is hello world, but it's all in lowercase. And so we're going to compare these strings, but we're going to ignore the case of the letters. We're going to ignore upper and lower case as we're doing that. So our first for loop compares the first two strings. And it does so by converting each one of their characters to uppercase using the toUpper function that's provided in the standard C library that's defined in the ctype.h file, header file. And so it's going to loop through comparing them. And then at the end it's going to say whether or not they're the same if we ignore case. The second for loop is going to compare the second and third strings, converting each to uppercase again to do the comparison, and then it will display a message whether or not those are the same. So when we run this program, it tells us that the strings, the first two strings, the one that contained hello world and the one that contained hello world in lowercase, if we ignore the case of the letters, they're the same string. And so there may be quite a few times where you want to be able to do string comparisons, but ignoring the upper and lowercase letters. And this program shows you how. And so as you work with strings, there may be times where you want to convert the string's contents to either uppercase or lowercase. And so this program does just that. And so it defines a character string called string1 and assigns it to characters hello world. You can see that it's a mixed case. It uses an uppercase H and lowercase letters and an uppercase W and lowercase letters. But we're going to convert it first to lowercase. And the way we're going to do that is loop through the entire string, one character at a time, until we hit that null character. And then we look at the character and say, if it's greater than or equal to an uppercase A, and it's less than or equal to uppercase Z, that tells us it's an uppercase letter. And we're going to convert it to lowercase. And so the math to do the conversion to lowercase is kind of interesting. You probably want to Google an ASCII chart so you can see that lowercase letters actually appear in the ASCII chart after the uppercase letters. So to convert a letter from lowercase to uppercase, we need to add to it the difference between the number of characters that are in a lowercase a and an uppercase a. And then in our next loop, so we're going to print out the lowercase one, and then we're going to convert to uppercase. And we're going to do that the same way, one character at a time, looping through until we encounter a null. And we're going to convert to lowercase by subtracting the difference between an lowercase a and an uppercase a. And so when we compile and run this program, we should see the following output. And sure enough, we have our strings in upper and lowercase. Depending on your program's processing, there may be times where you need to identify the first occurrence of a specific letter within a string. To do that, you can use the C library's strchar function, which searches a string for the first occurrence of a letter. And if it finds that, it will return a pointer to that letter's location in memory. And so we can test the value that it returns, and as long as it's not null, then it tells us that it found a pointer to it. And we can determine the index location in the string by subtracting the address of our string from that pointer. So if it found it at offset 0, our pointer and string address would be the same. If it found it at offset 1, our pointer would be 1 greater than our string address. Let's run this and it should make more sense. And so we run it, it says the letter L appears in hello at offset 2. Well, remember we're using zero-based arrays. So H is at offset 0, E is at offset 1, and the first L is indeed at offset 2. The way we determined that offset was to take the pointer that we got returned. And so the strchr function returned a pointer to that letter L. We took that pointer and subtracted our array starting address from it, and that gave us our offset. Just as there are times where your programs may want to find the first occurrence of a character within a string, there may be times when it wants to find the last or rightmost occurrence of a character within a string. To do so, we can use the strrchar, and the second R stands for right, function that's built into the standard C library, to return the rightmost occurrence of a character within a string. Again, the strrchar function is going to return a pointer should it find that character. Otherwise, it will return null. So we can check to see, is the pointer pointing to a character or is it pointing to null? If it's pointing to a character, we can then use that pointer to determine the offset of that character within the string. So when we run this program, we see that the letter L appears at the rightmost at offset 3. And that makes sense again because the H is at offset 0, the E is at offset 1, the first L is at offset 2, and the second L is at offset 3. So depending on the processing that your programs perform, there may be times where you have a character string representation of a number, an integer number or a floating point number or a long number, and you need to convert those to an actual number. A character string is just a sequence of characters. A number is a numeric value, and the C compiler stores a character string differently than it stores a number. And so you can't do arithmetic operations, multiplication, division, on a character string, for example. And so older C programs will use functions, and ATOI stands for ASCII to integer, ATOF is ASCII to float, ATOL is ASCII to long, and we can use these functions to convert a character string representation of a number to the corresponding actual number. And so that's what this program does. And so it uses the functions to convert several strings to their integer, floating point, and long values, and then displays them. And it also shows a function called strtod, which does a similar thing. And so the strd will return the value that it got to when it was parsing the characters. And so if it reaches the null character, then it got to the end of the string. If it didn't, it will point to the character that caused an error. And so older programs will use the ATOI, ATOF, ATOL. Newer programs should use the strod function. Let's go ahead and run this. And you can see that it converted our values appropriately, so we could treat them as integers, floats, and longs. And so there's a variety of functions you can use to convert strings to numeric values. And so again, you'll see the ATOI and ATOF and ATOL in older applications. The new preferred format is to use the strtod function.